Alright, here we go. We're going to work problem number 34. And it says you are driving a vehicle with a mass of 1,350 kilograms and you need to make a turn on a flat road. The radius of the curvature of the turn is 76 meters. The coefficient of static friction and the coefficient of kinetic friction, in this case you're going to be using kinetic friction, are both 0.25 or 1/4, and wants to know what is the fastest speed you can drive and still make it around the turn. Okay, so here we have our car and our curve, right? Here we have our radius, and we'll go outside and we'll draw the forces. We'll have gravity, and we'll have the normal force, and we'll have frictional force, right? And frictional force, and we'll have a centrifugal force. And for centrifugal force, we'll use Fc. Okay, so it tells us our mass was 1350 and our radius is 76 meters, and this coefficient right here, this kinetic frictional coefficient, is 0.25, and we know that G over here is 9.8 meters per second squared. Okay, so the first equation that comes to mind is that our coefficient is going to be equal to the frictional force over the normal force. So I got a tangent relationship. Okay, and the next thing that comes to mind is this centrifugal force, which is equal to your difference in momentum over difference of time, and that is equal to the mass times velocity squared over our radius. If you take that and count that the normal force right here is going to end up equaling this over here, because I got to cancel out, right, equals mg, and you will now have that, let's see, you'll have F over here, you have to do some algebra, F, and you just multiply over here, equals this coefficient times mg. And if you okay, so here we go, F net, right, F net in this case equals 0, right, at the max speed. And really we only need to take into account that F net is going to be equal to, we're really only worried about the centrifugal force and this frictional force, and since we have 0 equals our Fc, which actually can be represented by mv squared over r minus, we determined that frictional force is now equal to this, and we move it over here, we get UK times mg equals mv squared over r, multiply, you can't even see what I'm writing, multiply times r, mg times r equals mv squared, and then you would divide by m, and then you would take the square root, so you're going to have the square root of this coefficient, this normal force, your radius, and your mass cancels out, so it's just this, and that'll equal your final velocity. And this video already took too long, but you can figure out the numbers. Okay.